Today, electricity has become one of the essential requirements of our life. Efforts are being made to bring electricity to the remotest corners of the country. The cool air which we get from air conditioner or desert cooler, the program we see on the television, and many other comforts are due to availability of electricity. While electricity is being utilized by one and all, it is essential that the installation and maintenance staff, as well as the users, are aware of the factors which influence the safe and efficient use of electricity. With this aim, in this film we shall show you various types of domestic wiring systems, precautions to be taken, and stress the do's and don'ts, preventive maintenance, and rectification of faults.
Electricity is generated in powerhouses. These powerhouses are generally situated at distant places. Electricity generated at powerhouses is to be brought to the places of its use. This is done through transmission lines. Electricity generated is first stepped up using a device called transformer to high voltage, say 400 or 220 kilovolts, and then connected to the transmission lines. At the other end of the transmission lines, electricity is received through another transformer which steps down the voltage to lower levels at substations. For example, 400 kilovolts or 220 kilovolts is first stepped down to 66 kilovolts and sent to various places. In the second stage, 66 kilovolts is further stepped down to 11 kilovolts. "11 kilovolt lines are run around the cities and towns where electricity is further stepped down to 415 volts. Finally, through the service mains, electricity enters the house. A service main is a cable connecting the distribution lines and the consumer main board. Service main should be a cable of standard make and of adequate size to meet the maximum demand of the house. The service main may be overhead or underground. This is how the connections are made for underground service main, and this for overhead service main. Let us now see the other components of a wiring system. The first of these components is the main board, which houses energy meter, main switch and distribution box. Power from the service main flows through the energy meter and the main switch to the distribution box, from where it is fed to the various circuits. In a domestic wiring installation, two types of circuits are drawn. One is called light circuit and the other power circuit. Light circuit caters to fans and lighting load, whereas power circuit caters to 15 ampere socket outlet loads. This is done to achieve reliability and economy. This is the main switch and distribution box for light circuits. Similarly, there is a separate main switch and a distribution box for power circuits. The line and the neutral is taken forward by incorporating the fuse in the line and a link in the neutral. The switch fuse units these days are being replaced by miniature circuit breakers. Facility for spare connections is provided for future expansion. Earth leakage circuit breakers, also called ELCBs, are incorporated in the main board for safety reasons. The wiring of light and fan circuits as well as the power circuits can be done in different ways. Thus we have the following types of wiring systems: batten wiring, casing and caping, conduit wiring, that is surface conduit wiring or recessed conduit wiring, and cleat wiring. The batten wiring is very simple and economical. In this, the sheathed PVC cables run on well-seasoned and varnished teakwood battens. The wooden battens are 10 mm thick and of variable width. The width of battens used will depend on the number of wires to be run on them. Battens should be secured to the walls and ceiling with the help of wooden gutties. Rowel plugs are preferred over gutties nowadays. Link clips should be fixed at an interval of 10 cm in case of horizontal run and 15 cm in case of vertical run. Smooth curve should be given at the turning point. The distance between gutties should not exceed 75 centimeters. In casing and caping wiring, PVC cables are carried in grooves of wooden casing, which is then covered with wooden caping. This system has been replaced by batten wiring because of its high cost. Presently, the most commonly used wiring method is the conduit wiring, where the PVC cable runs through the conduits. In surface conduit type of wiring, steel or PVC conduits are fixed to the walls and ceilings with the help of saddles and staples. Whereas, in the concealed conduit wiring, the conduit is embedded in the wall before finishing. In concealed wiring, first a suitable chase is made in the wall. PVC or the steel conduits are then laid in the recess and held to the walls with the help of hooks. The recess is then filled with plaster to make good the broken surface. Suitable inspection boxes are provided for ease of drawing cables and maintenance. Elbows should be used at the turning points to avoid 90-degree bends. Cables are pulled gently through the conduits with the help of GI wire. Cleated wiring is used only for temporary installations. The PVC cables are held to the walls and ceilings by means of porcelain cleats. This system is scarcely used these days. The quality of wiring can be improved if following points are kept in mind. Layout of proposed wiring should be drawn beforehand. Size and type of cable should be selected based on requirement. Normally, 1.5 square millimeter cables for light circuit and 4 square millimeter cable for power circuit should be used. Phase wire must be connected to control switch and proper color code should be followed. Interlocking type switch socket combination fittings should be used for safety of the users. Proper geometry should be maintained while fixing various fixtures. Don't hammer the screws. Instead, tighten them properly with the help of a screwdriver. Light and power points should be kept on separate circuits. Limit light and fan points per circuit to 10 and power points per circuit to 2. Leave extra length of cable at each connecting point for ease of connection and maintenance. Appliances of high rating such as geyser, air conditioner, water cooler, heater, etc. should be provided with 15 ampere socket. Provide rubber bushes at all cable entry points to avoid damage to insulation due to sharp edges. Steel conduits must be electrically continuous and effectively earthed. All electrical connections must be tight enough to ensure electrical continuity and safety of the wiring system. Always locate the switchboard near the entrance of the room, and first switch should be that of light. Bell switch should be so located that it is convenient to the visitor. Provide two-way switch for staircase light. For better aesthetics, proper utility and easy maintenance, keep the height of various fixtures as suggested. Bracket light fittings 215 centimeters, switches and fan regulator 100 centimeters, power sockets 100 centimeters, bathroom light over mirror 200 centimeters, geyser socket 215 centimeters, clearance between the floor and the ceiling fan 240 centimeters, minimum distance between the ceiling and fan blades 30 centimeters. Provision of earthing as per relevant electricity rules is essential to provide adequate safety to the users and the wiring system. Improper earthing may lead to fatal accident. Ensure earth wire runs along each circuit. Earth wires of all circuits must be effectively connected to the earth terminal on the main board. Let us understand how the earthing is done with help of this diagram. Copper or GI plate is used as earth electrode, which is buried at a minimum depth of 2.15 meters with a required quantity of salt and charcoal around it. It should have watering arrangement. Copper or GI wire of suitable gauge is connected to the earthing plate and runs through the GI pipe. This earthing wire is finally brought out and firmly connected to the main board. Earth pit resistance should not be more than 5 ohms. Also ensure earth continuity. Here are certain additional guidelines for carrying out proper wiring. Length of PVC cables should not fall short. Maintain proper geometry. Avoid too many extensions of circuits. Provide switches at convenient height. Use proper plug top for safety reasons. Do not replace fuse grip with cable. Use proper fuse. Like any other system, regular repair and maintenance is essential for proper functioning of house wiring system. Although ultimate responsibility of proper maintenance of house wiring rests with the maintenance staff, particularly in public buildings, but users' knowledge about the system and their cooperation is essential. For longevity and efficient functioning of house wiring system, user can contribute to a great extent by observing few guidelines. Use electricity for essential requirements only. Don't use overrated fuse. Use standard appliances and accessories. Avoid use of light circuits as power circuits and vice versa. Avoid use of appliances without earth terminals. Do not tap service line. Do not tamper with power meter. Ensure timely rectification of faults by trained electrician. Use plug top having earth terminals. Ensure use of energy up to the authorized scale only. The user must have house wiring diagram and it should be displayed in the main board. This will help the technician in quick identification and rectification of faults. The technician attending to house wiring must have proper tools, equipments and spare fixtures. He should carry the following tools: insulated screwdrivers of various sizes, insulated plier and adjustable spanner, hammer, hacksaw and poker, phase tester and test holder with lamp, hand drill and chisel, insulated hand gloves and safety belt, and multimeter. Electrician must be good in public dealing and must listen to the user's requirement with patience. Electrician must be well trained and should undertake the repair only after understanding the system well. If you take care of wiring system by adhering to the salient points discussed earlier, you can be sure of long and trouble-free service.